In this video, we will talk about the evaluation functions and why and how evaluation functions use training, validations, and testing datasets to help us in evaluating the models. Let's get started. To evaluate the generalizability of the final models, it's always important to use the data that the models was not trained on, namely testing data. That means the model has never seen this data before. There's a simple way to split all the samples into two datasets. And the first dataset is the training, testing, and validation dataset. And these datasets, will be passed on to the fit functions. And then according to the fit functions, it can then further use it to split the samples into the trainings and validations dataset. And the arguments of such functions includes the validation split or validation data from the fit functions. We will intentionally separate some data from the entire dataset, from the training datasets and validations datasets, and that is called the testing data. And these testing data is used to provide an unbiased evaluations to the entire model. So once the model is completely trained, these unseen testing data sets can be used to evaluate how well or how bad the models perform. And it's always considered as a good practice. So let's take a look on these flow charts. First of all, we have all the data. And these data will be split into two datasets. For the first one, that is for the training dataset and validation dataset on the left-hand side of this diagram. And then the second part is for the testing stats in the right-hand side of this diagram. And then for the training and validation stats, it will further split with the fit functions. And training data will be used to train the models and calculate the estimates and compare with the true value and with the use of the loss functions, and it will calculate the training loss. Once we have this training loss, the optimizers will calculate the gradients, and of course with the use of the gradient descent methods, and it will then update the parameters W and B and continues to train the models. In the meantime, for every epoch, it will also pass the models to the validation set data. And these validation data sets will then calculate the estimate and compare with the labels and pass it on to the loss functions to calculate the validation loss. And of course, this validation loss will not be used to update the parameters W and B, but will give us a sense how well the models is performing. And remember that this validation loss is quite important when we are talking about the generalizability, because it will help us to determine the early stopping criteria so that overfitting issues can be avoided. Therefore, for each epoch, the fit functions will show us the training loss based on the training dataset, and also show us the validations loss based on the validations datasets. And once everything has been completed, the model has been trained, we will then pass it on the final models to the testing dataset, and then the test with the use of the testing dataset, we will calculate the estimates, the predicted y hat, and then compare it with the true y and calculate the test loss. And this test loss will give us an unbiased evaluation of the trained model. The main reasons why it's unbiased is that the training and validations datasets normally we will perform normalizations or standardizations before we train the models for the entire datasets to improve the training process. And the trainings and validations data are very often will consider as a whole to perform normalizations or standardizations. Therefore, the validations data will know the distributions of the training dataset, and hence it calls an unbiased evaluations. To avoid these issues, we will first hold out some data from the entire dataset, which is called the testing dataset here. And these testing dataset will have no ideas about the distributions of the training and validations dataset. Therefore, the evaluations is unbiased. And in Keras, we can use the evaluate to return the test loss or the matrix values according to the arguments provided in a compile functions. Now let's take a look on an example. We first import the sequential models and also dense layers, and also we import the NumPy. Let's run this cell first, and then we set up the inputs and outputs data with the random value. What we are going to do is that we would like to split the 100 samples, we have 100 sample here, into two data sets. So we are going to use the sklearn model selections, the functions called train test split. We are going to use these train test split functions. We provide the input and output data, and also we are going to hold 10% of the data as the testing data. And we are going to give this a random state, 1 to 3, so that later on, if we want to get back this speed, we can just provide this 1 to 3 again. This is the random state value. And now let's take a look on the training and validations data set about their shape. The training data set that we have is 19 and 90 for the inputs and outputs. Of course, we have 3 inputs and 1 output. And then here you can also see that the testing data set, just like what I mentioned before, we are going to hold out 10% of the data. And so we have 10 samples here. Now, just like what we've done before, we create a sequential models, and then we are going to add the first layer with 2 neurons, add the last layer with 1 neuron, and we're going to compile the models with the Adams optimizers, with MSE as the loss functions, with MAE as the metrics. Let me run this. And of course, finally, we can use the fit functions to split the 90 samples into training and validations dataset. And here we just provide the X train and Y train, that is the input data and output data. And then we provide a validation split 0.2. That means we're going to use 20% out of these 90 samples for the validations, and the rest will be used for training. And let me run this cell. Therefore, here we have the trainings loss and also the training metrics, that is for the MSE of the training dataset and MAE of the training dataset. And here we have the validation loss and also validations metrics for the validations dataset. And that is the MSE for these validation datasets and also MAE for these validations dataset. And finally, just like what I mentioned before, we can use the evaluation functions to evaluate the testing datasets. And if I run this by providing the testing data that we spit out at the very beginning, and then we can use these .evaluate functions to calculate the testing loss and also testing metrics. just like what we have before. We have these MSE for the testing data and also MAE for these test data sets. With all these loss values and metrics, we will be able to evaluate how well or how bad our model is performing. And according to the model's performance, we shall be able to continue to improve the models with appropriate measures if it's not performing well. I have a video showed before how to render bias variance diagnosis to assess the model's performance. Please also feel free to find more information on how to use training, validations, and testing loss to evaluate a deep learning models over there. And that's it for these videos. In the next video, I will show you how to use the training models to perform predictions. See you in the next video. Bye-bye.